This is the Unit 8 vocabulary. So we're going to start out with a conic section. A conic section is any figure that can be obtained by slicing a double cone. And what that means here is we have two cones pointing at each other, and we take a plane or a slice of this double cone shape. And out of that we can get a circle, an ellipse, a parabola, hyperbola, a point, a line, or two intersecting lines. All of these are conic sections. Moving on here, we're going to talk about some attributes of a parabola. First one is a focus. The focus is a given point in a parabola, and along with that is a directrix, a given line in a parabola. Using the focus and directrix, you can actually draw any point on the parabola. Also, let's use that as for the definition. A parabola is the set of all points in a plane that are the same distance from a given point, the focus, here in red, and a given line, the directrix, here in gold. For example, if we want to see the distance here from the focus to an arbitrary point, let's pick that one, and we go straight down to this directrix line, these lengths are going to be exactly the same. We can do that again over here, pick a new point, and these lengths here will be exactly the same. No matter where you pick, it's going to be exactly the same length from the focus to a point on the parabola and the directrix to a point on the parabola. Last one here, we have the latus rectum. That's the green line going across. It's the line segment through the focus of a parabola, so it goes through the focus point, and it's perpendicular to the axis of symmetry. So here's your axis of symmetry going up and down. The latus rectum is perpendicular. Continuing on here, we have a circle. A circle is the set of all points in a plane that are equidistant from a given point in a plane, and we call that point the center. So if you go from the center to any point, you're going to have the same distance. And of course we know that that length there is called a radius. Second vocabulary word here is a tangent. A tangent is the line that intersects a circle at exactly one point. And you can see how it does not cross at multiple points like a chord would, but it touches at exactly one point. Continuing on, we're going to look at different types of variation. First one is called direct variation. This means that y varies directly as x if there is some non-zero constant k such that y equals kx. And in this case, k is called the constant of variation. So y equals kx. The variables are on different side of the equal sign when there's no fraction. So that's one way to know that you have direct variation. An example of this in real life is, for example, the radius and circumference of a circle. As the radius gets bigger, the circumference gets bigger. As you get older, you get taller. Things like that. These are in direct variation. Inverse variation. Y varies inversely as x if there is some non-zero constant k such that xy equals k, or y equals k over x. What this means here is that as y goes up, x goes down. When there are no fractions, x and y will end up being on the same side of the equal sign. So unlike direct, where when there's no fractions, they're on opposite sides, with inverse relationships, they're on the same side when there are no fractions. Finally, we have joint variation. Y varies jointly as x and z. That's the key to joint. There's two variables. If there's some non-zero constant k such that y equals kxz, where x is not 0 and z is not 0. What this means here is it's just like direct variation, except instead of varying with only one variable, it varies with two. An example would be the area of a rectangle varies based on the width and the length. So you can increase either one and it will make the area go up. Or you can increase both and it would go up. Finally, we reference this quite a bit, the constant of variation is that letter k. The constant k used with direct or inverse, or in this case, joint variation. That constant could be any number. It could be 1, in which case you wouldn't see it written down explicitly, or it could be any positive or negative number. Moving on, we have a bunch of things with rationals. First one is called a rational function. This is an equation in the form where f of x equals this expression here, p of x over q of x, where p of x and q of x are polynomials. Remember that a polynomial means that it's something like 2x plus 1, where it's x to the first power, or x squared plus 2x minus 8, x to the second power, x to the first power. A polynomial has no square roots, no fractional exponents, no exponents or no variables in the exponent. It just has the natural numbers, the counting numbers in your exponents here. Continuing on, a rational equation is any equation that contains one or more rational expressions. So here we have these expressions on either side of the equal sign, and that would be considered a rational equation. A rational inequality, very similar, except it has an inequality sign. So in this case, a 2/3 is greater than the rational expressions on the other side. Finally, a complex fraction is when you take a couple rational functions and you divide them by each other. So in the numerator of this fraction here, we have a complex, or we have a rational function. In the denominator, a rational function. That forms a complex fraction. Continuing on here, we have an asymptote. An asymptote is a line that a graph approaches but never crosses. So here's an example. Usually it's drawn as a dashed line on most graphs. You'll have certain functions where the line will approach it, and never quite touch that line. It'll go up towards infinity. On the other side, this isn't always the case, but in most cases on the other side it's coming from the opposite direction. And again, never touches that line. Finally, let's look at a continuity. A continuity is the graph of a function that can be traced with a pencil and never leaves the paper. For example, it doesn't really matter what crazy stuff is going on here. I never picked up my pen. I just continue on. It's a continuity. The best way to understand continuities is through its opposite. A hole or a discontinuity would be an example of something that is not continuous. You would have to pick up your pen. An asymptote is another thing that causes discontinuity. You can see you can't continue tracing this on forever because you have a break. And that's the Unit 8 vocabulary.